Hello, my name is Alan Winfield. I'm Professor of Electronic Engineering here at the University of the West of England, Bristol, and I conduct my research in the Bristol Robotics Laboratory. So I'm going to talk about the ethical roboticist. And this talk, it will be in two parts. So the first part will be concerned with robot ethics. I'm going to briefly introduce robot ethics. And in part two, kind of turn to the opposite question, which is how robots themselves can be ethical. So I'll go from how humans need to be ethical to how robots might themselves be ethical. So, but first of all, before getting into robot ethics, I want to tell you a story, a true story. So in 2009, I had a call from the Sunday Times. It was a Friday afternoon, and it was the science correspondent from the Sunday Times. And he asked me on the telephone, did I know that there was a meeting of the American Association for Artificial Intelligence to discuss robot ethics? My answer was no, I didn't know that, which is true. I didn't know they were meeting. And then he said, am I surprised that there was a meeting to discuss robot ethics? And I said, no, of course not. I mean, this is what we do. This is normal work for roboticists and computer scientists to worry about the ethics. So really there wasn't a story. I guess the story would be scientists behaving responsibly. And I didn't expect anything to appear in the Sunday paper. So on Sunday, I was very surprised, therefore, when I saw this headline: "Scientists fear a revolt of killer robots." That's you can see it here. And if you look at the small print of the article, it says scientists are privately so worried that they may be creating machines which end up outsmarting us. They held a secret meeting behind closed doors. Of course, none of that is true. None of that is true. It was an open meeting. So this really just illustrates the problem with robot ethics and the press and media. So let me then proceed with part one of the talk, chastened, if you like, by that story of how even if you do behave ethically, the press don't believe you, or they question your motives. So what do I mean? What do we mean by ethics or ethical harms? Well, really there are four categories of ethical harm that we need to be concerned about. And these are very simply unintended physical harm. That's fairly obvious. We think of that as safety. Psychological harms we need to worry about. We need to worry about socioeconomic harms, clearly, but very importantly, not to miss out the environmental harms. That's also an ethical consideration. So really, if you're an ethicist or like me, a robo-ethicist, you need to be concerned about how to minimize or mitigate all of these ethical harms. Now, what I'd like to do in the next few slides is just to pick out four ethical problems. Now, there are many, many more than four, but I've just chosen four to be kind of representative of the kinds of things that well, not only people like me, but ordinary members of the public worry about with robots. The first one is perhaps perfectly obvious, and this really reflects perhaps the biggest fear that people have about robots, which is that they'll take away jobs. It's the problem of robots that displace jobs. Now, I don't want to debate here the issues of robots and jobs. That would take a whole lecture. But suffice it to say that this is a serious societal issue, and it's one that we need to worry about. My second ethical problem I call the problem of robots that pull the trigger. So this is really a concern about military robots. And the concern here is about the trend in military robots from robots that are operated by human beings, so it's a human being who actually decides when the robot should fire its weapon, to robots that autonomously fire the weapon, so-called lethal autonomous weapon systems. Now, there are a number of pressure groups already concerned with this issue, notably the International Committee for Robot Arms Control, which is really seeking to a treaty to ban these lethal autonomous weapon systems. So that's our second ethical question. Our third one is what I call the ethical problem of humanoid robots that appear to be intelligent but are not. The robots you see here are very lifelike in appearance, but actually it's a deception because the robots are not much smarter than a washing machine. Now, I think this is an ethical problem because it's a robot that appears to be intelligent, but it is not. The fact is that we can build the bodies, but not yet build the brains. My own view is that I don't think we should be building humanoid and especially android robots until we really can build human equivalent artificial intelligence. My third and final ethical problem, what you can hear right now is the Paro robot seal. The problem I want to highlight is what I call the problem of robots that induce an emotional response or possibly dependency. This robot, the Paro robot, has been used to very good effect to comfort elderly people. But should we worry about robots that might deceive someone into believing that the robot actually cares for them? I think that's a really good ethical question for roboticists. So those are the four ethical issues that I really wanted to give as an illustration of the kinds of ethical concerns that we need to worry about. Now, back in 2010, I was part of a working group that drafted a set of principles of robotics, in fact, five principles of robotics. And I'd like to now show you those 5 principles. The first one really echoes Asimov's first law of robotics, which in fact I'll come back to Asimov in part 2 of the lecture. And this principle really illustrates or highlights the fact that robots can be used for all kinds of things. They're a kind of Swiss knife. They can be used for all kinds of applications. But importantly, as we've written here, robots should not be designed solely or primarily to kill or harm humans. So this is really the ethical principle of no harm. You'll notice that there is this qualifying clause, except in the interests of national security. I have to say that I was not happy about that personally, but this was the work of a committee, and of course you have to take the consensus view. The thinking behind that, except in the interests of national security, was that if we want a set of ethical principles that everyone can sign up to, including people who work in the defense sector, then of course we really need to have that clause. So, I understand the reasons for that. Our second ethical principle really makes the point that humans, not robots, are responsible agents. A robot cannot be responsible, either for itself or anybody else. And this principle also points out that robots need to comply with existing laws and freedoms, including privacy, human rights, and so on. Many roboticists, particularly research roboticists, tend to imagine that robots are somehow outside existing legislation. Of course, that's not true. And these principles really serve to illustrate the fact that there's lots of existing law, data protection, human rights, and so on, that applies equally to robots and must and should properly apply to robots. Our third principle is very simple. Robots are products, and that means that they have to be designed to meet all of the regular safety and security standards and protocols that exist. That's a fairly obvious thing to say, but again, this needs to be stated. You know, this needs to be part of the ethical principles of robotics. Our fourth principle, which reflects the ethical concern that I raised earlier about robots that might deceive, is that robots are manufactured artifacts. And we've written here that they should not be designed in a deceptive way to exploit vulnerable users. Instead, their machine nature should be transparent. Rather like Toto in The Wizard of Oz, it should always be possible to pull aside the curtain and realize that this is a robot and not a person. So that's our fourth principle. Our final principle, ethical principle, is that the person with legal responsibility for a robot should always be attributed. In other words, robots should have a kind of license plate so that you should always be able to find out if, for instance, a robot is involved in an accident or causes some damage. You should always be able to find out who is legally responsible for that robot. So those principles were published. In fact, the link is here on the slides in 2010 and have achieved quite a lot of traction, which is great. And since then, I've been involved as part of a group working with the British Standards Institute. And I'm very pleased that just a few months ago, in April 2016, we published British Standard 8611, which is called A Guide to the Ethical Design and Application of Robots and Robotic Systems. So I believe this to be the world's first published standard for robot ethics, which I think is a really important step forward. That brings me to the end of the first part of the lecture on how humans should be ethical, in particular roboticists, and not just roboticists, but designers, manufacturers, maintainers, suppliers of robots. But now I want to turn to the question of whether robots themselves could be ethical. So, is it possible to build a moral machine? Is it possible to build a robot capable of choosing or moderating its actions on the basis of ethical principles? Now, 3 years ago, I thought the idea completely impossible. But since then, I've changed my mind. So, what brought about this U-turn in my thinking? Well, first, it was thinking about very simple ethical behaviors. So imagine you see someone not looking where they're going. They're perhaps walking along a pavement, looking at their smartphone. Of course, that never happens in real life, does it? And they're about to walk into a hole in the pavement. Now, you will probably intervene. Why is that? Well, it's not just because you're a good person. It's because you have the cognitive machinery to be able to predict the consequences of their actions. And, in fact, your own actions should you intervene. So you can figure out whether they're likely to fall into the hole and whether you might be able to save them. So, but now imagine that it's not you, but instead it's a robot. And you can see in the slide here that the robot has four next possible actions. It can stand still, that's action A. It can turn left, in which case it avoids the hole. If the robot goes straight ahead, then it will fall into the hole. But if it turns to its right, it might collide with the human. And a collision with the human actually might save the human from falling into the hole. So the possibility opens up, therefore, if we think about this very simple scenario, that the robot could choose to collide with the human to prevent that person from falling into the hole in the ground. Now, if we write this down as a logical rule, the rule remarkably appears to match Asimov's first law of robotics, which is a robot should not harm or, through inaction, cause a human to come to harm. And thus emerged the idea that we might be able to build a robot with Asimovian ethics, a robot that literally is, if you like, 3 laws safe. And here, just to remind us, are the Asimov's 3 laws of robotics. What we need is to equip the robot with the ability to predict the consequences of its own actions and its own and others' actions. And in addition to the ability to predict actions, it also needs to have the ethical rule that I showed in the previous slide to decide which of those actions to choose. So that was the first part of my thinking, the kind of realization of how you might build an ethical robot. But then came the realization that the technology that we need to do this not only exists, but is mature and commonplace. And it's the robot simulator. And what this slide shows is a typical robot simulator. We use these all the time in robotics research. So typically, we use a robot simulator to allow us to test the code in our robots in a simulated environment before actually trying the code out for real on the real robot. So the idea of embedding a simulator in a robot is not new, but it is kind of tricky, and not many researchers have done it. It kind of takes a bit of getting your head around. The idea is that the robot has a simulation of itself inside itself. In fact, a simulation of not only itself, but the others in its environment inside itself, as I've illustrated on the slide here. And just to get a little bit more technical, we call this internal simulation a consequence engine, because it's the, if you like, it's the cognitive machinery, the artificial intelligence, in fact, to allow the robot to predict the consequences of both its own and others' actions in its environment. Now, over the past 2 years, we've succeeded in building an ethical robot, in fact, several ethical robots based on these ideas. So these robots have typically a consequence engine built into them. So here you can see the robots. We have on the left some epoch robots. These are small wheeled robots, Swiss robots. And on the right, we're using more recently the now robots, the humanoid robots by the French company Aldebaran Robotics. The work that I'm going to show you now, the experimental work, was done by my colleagues Dr. Christian Blum and Dr. Dieter van der Elst. Now, we don't have a real hole in the ground. We just have a kind of area marked out on the lab floor, which you can see in yellow in this image. Now, this is the experiment with the epochs. The A robot, A for Asimov, is our ethical robot. And the A robot has to itself go to a goal position, which is marked on this slide. The H robot, H for human, is heading in the direction of the hole. And the A robot needs to both keep itself safe, in other words, safe from falling into the hole, but also prevent the H robot from coming to harm. And I'll now show you a movie which actually shows this in progress, this experiment in progress. You'll see it first in real time, and you can see that the A robot notices the H robot, diverts from its path, and has a gentle collision with the H robot, which then goes off safely in another direction. The A robot then continues to its goal position, avoiding the hole. In fact, you can see that the movie is now speeded up, and you can see quite a number of runs, I think around 30 runs of this experiment. And importantly, the A robot prevents the H robot from falling into the hole every time. So it's 100% successful at preventing the, as it were, the H robot from coming to harm. So what we see here is a movie clip of exactly the same behavior as in the previous experiment with the epochs, but this time with the humanoid now robots. This time the blue robot is our ethical robot, our A robot. The red robot is the human, and the two wooden posts that you can see here represent both the goal position. So on the left is the goal position for the ethical robot. On the right is the danger position for the human robot, the H robot. And what we see, just as before, is that the ethical robot notices that the H robot is heading toward danger and diverts from its path in order to physically prevent the H robot from coming to harm, before then continuing the ethical robot then continues towards its goal position. So that's great. That works fine. Now, when we wrote this work up to publish, it was kind of a bit boring because we realized that the paper said we've built this ethical robot and it works, which is kind of really a little bit dull. So I said to my colleagues, let's run the same experiment, but instead of one human, let's have two humans. So let's give our ethical robot the task of resolving a dilemma, an ethical dilemma. So which of the two humans can it save, if either of them? And in this movie, what you see is, again, the epochs, but now we have two H robots, the H and H2, both heading at the same time for the hole in the ground. And what you see here is, no, the A robot tried to save one of them, but in fact is too late. So both of the H robots have fallen into the hole, which is really strange because we know that the A robot can save at least one H robot all of the time. And in fact, if you see the speeded up version of this experiment, you'll see that the A robot does manage to save one of the human robots, the H robots, some of the time, but actually much less often than we'd expect. So, this really puzzled us. We thought, well, why is it that that our ethical robot, we know can save one of the H robots all of the time, now in fact is only saving one of them perhaps less than half the time, something like 40 or 45% of the runs, the A robot only managed to save one of the H robots. Around 50% of the time, in fact, both of the humans fell in the hole. So what's going on? Well, if you look very carefully at that movie, you can see a behavior which is dithering. So we realize that the problem is that we realize that the problem is that the A robot is able to change its decision. So because it runs the consequence engine 2 times a second, it's able to change which direction it's moving in, if you like, twice a second. And this is what causes the problem. The problem is that unwittingly we've built a very indecisive robot, kind of pathologically indecisive robot. It's a robot that changes its mind. It's like, imagine that you find yourself in the same position. There are 2 people both heading for danger, and you say, right, I'm going to save that one. No, I'm not going to, I'll save the other one. No, I'll go back to the first one. And of course, if you do that, if you're indecisive in that situation, you'll probably end up saving nobody. And that's exactly what's happening in this experiment, which was really a surprise, but quite fascinating. And we tried the same thing here with the now robots, and oh yes, the robot is changing its mind. It's too late. It can't save the one on the right, so it's now going to save the one on the left. So, in fact, exactly the same kind of dithering, indecisive behavior is evident in the experiment with the now robots, which is, again, very, very interesting. So, what kind of ethics does our ethical robot have? Well, in fact, it implements a form of consequentialist ethics. And, of course, that's not surprising, given that its internal simulation is what we call a consequence engine. But the important thing is that our robot behaves ethically not because it chooses to, but because it's programmed to do so. It's hardwired to behave ethically. It's what we call an ethical zombie. It is capable of ethical actions, but without understanding what it's doing or why it's doing it. Now, I think that even simple, minimally ethical robots, ethical zombies, could be very useful, could be valuable in real-world robotics. Now, this approach, I would argue, has a big advantage. So the important thing is that the internal processes of making ethical decisions are completely transparent. That means that if there's a problem, if the ethical robot does something that we don't expect, then we can actually replay what was going on in the consequence engine at the moment that it made a particular decision. And I think this is going to be really important in the future. And this slide, in fact, shows an ethical black box. So I think that future robots will need the equivalent of a flight data recorder on aircraft that allows you to find out, to replay exactly what was going on at the moment that the robot made perhaps a surprising or unexpected decision, perhaps made the wrong decision, in fact. So what I call an ethical black box. So what have we learned? Well, I think the biggest lesson that we've learned from this work on ethical robots, and a real surprise to me, is that robots do not need to be sentient in order to be ethical. In other words, we really do not need a major breakthrough in artificial intelligence to make at least minimally ethical robots. So we really do not need to build data from Star Trek in order to make an ethical robot, which I think is a really interesting conclusion. And what I'd like to do is to finish with a question about a difficult question really, about the ethics of ethical robots. So if we can build ethical robots, are we ethically compelled? Do we have a moral imperative to build ethical robots? Do we have a moral imperative to do so? I think it's a very difficult question. It's really a question for moral philosophers, for ethicists, rather than engineers like me. But I think with driverless cars just around the corner, I think it's a question that we will need to address. If you think of driverless cars, they are likely to encounter situations in which the car has to make a decision where perhaps the decision is a difficult one. It may not be an ethical dilemma, but certainly the decision might be between potentially harming the passengers or harming somebody else on the road. Now, that's certainly an ethical decision. So I think the question of whether we should make ethical robots is one that we will have to face. And maybe the kind of approach that I've illustrated here might help in that direction. So in conclusion, I'd like to make just a couple of points. Really the first point is with regard to robot ethics. It's very, very important that we have an open, transparent public debate about the societal, ethical and economic impact of robots the ethics of robots, both roboticists and robots, really is something that needs to be determined by the whole of society, not just by people like me. So I think public debate is really important. And really all of that needs to be done in the context of responsible research and innovation. I think the overarching philosophy is that we need to innovate responsibly and ethically. So at that point, I'll conclude the lecture and say thank you very much for listening. Thank you.